As you know, Thales is a business-to-business company which operates within critical systems. This is very important. So we are not doing the same technologies as the GAFAs, for example. We are not doing the everyday applications. We are doing applications for systems which are very critical, where life can be at stake, where defense missions can be at stake, where finance transaction can be at stake, because Thales cyber secure a large proportion of credit card transactions, for example, and all these systems are critical systems. I usually say that when Netflix recommends you a movie you don't like, so it's not a big deal. You just pick up another one and that's it. Now, if you are taking a flight, and provided that 2 aircrafts out of 3 in the world take off or land thanks to Thales systems, because they embed FMS, for example, flight management systems, which are the brain of the aircraft, or because they are within our ATM system, air traffic management system. So if these systems involve AI technologies in some way or another, so it's better that you can trust these systems. And this is what we have been really pushing ahead, this idea of trustworthy AI. It's, in this case, also teams specialized on explainable AI. We have, by the way, a joint lab with other French industrials as EDF and Total Energy. So these are 2 French. Total Energy is the oil company, so we know this company also. So we have a joint lab, it's a physical lab in Saclay, south of Paris, on 3 topics on artificial intelligence. The name of this joint lab is called Sinclair. SINCLAIR, and this lab is on 3 topics. One on XAI, explainable AI. The second topic is on what the so-called reinforcement learning. It's very promising technique in AI. It's even as promising as deep learning. And the third topic is on simulation, how to use AI for simulation. So I told you about the 2 first pillars for trustworthy AI, validity, explainability. The third pillar is security of AI systems. Security is the guarantee that our systems should be resilient and robust to any kind of malevolent behavior. And especially to cyber attacks. As you know, cybersecurity and AI actually have a very tight bilateral relationship. You have to cyber secure AI systems, and conversely, AI is used to design and build cybersecurity technologies, because AI by design has the ability to detect weak signals, for example, when there is a cyber attack which is prepared. So and to identify anomalies in some time series, for example, in some logs. And AI is also more and more used to decoy systems. I mean, to cheat, to tromper the system. So there is this kind of bilateral relationship, and in Thales, at Thales we have teams doing what we call friendly hacking. We have a specialized team now on friendly hacking, which actually the team attacks AI algorithms, try to identify the vulnerabilities of these algorithms, and to propose countermeasures to have a kind of remediation against cyber attacks. And what we would like to do is really to have this crash test in our engineering process, in our qualification and certification process. Now, it had been said everywhere that AI systems are not explainable. They are black boxes that you cannot explain why they are doing what they are doing, or why they are recommending what they are recommending, especially systems which are based on machine learning and deep learning, as you said. And this is why very early, actually it was in 2015, I think, 2016, where the DARPA in the United States launched a very big program on so-called XAI, explainable AI, how to make AI systems explainable. Because it's very important that you can explain, you can say why an AI system did what it did or recommended what it recommended, at least a posteriori, if there is a problem. And at THALES, actually, we are working on this issue, even to be able to provide explainability in real time, which means that we'd like our systems to be self-explainable. An AI system, say for example a digital co-pilot in a cockpit, which is supposed to augment the ability of the pilot, and if the digital co-pilot, digital assistant in the cockpit, recommends to the pilot to make a left in 45 miles, so the pilot should be able to ask why should they do that, especially if she or he had in mind to do something different. And the system, to ask for an explanation, and the system should be able to answer because there is a threat, if you are in a defense mission, for example, or there is a thunderstorm, and not because the layer number 3 of the neural net was activated at 30%. So providing explanation is not tracing the program, is just picking up the human concepts which could make an operator understand why the system is doing what is doing, or why the system is recommending what is recommending. And explanation and explainability in real time require, of course, to be very reactive. That means that if the pilot has only 5 seconds to make a decision, the system should be able to calculate the explanation and to deliver it in less than 5 seconds. Otherwise, it becomes counterproductive, and it would even overload the pilot in this case. Okay, so and the system has also to provide this kind of explanation, taking into account the context of, for example, the workload of the pilot, the cognitive load, and to tailor the explanation with respect of this cognitive load, not to overload the pilot, just to choose the right words, to be very synthetic in some cases, and if there is no cognitive load, to be as detailed as relevant.